Sustainability of edible insects. Edible insects are considered the protein of the future because they have a much smaller environmental footprint compared to traditional livestock. They require less land, water, and feed, and produce fewer greenhouse gases. This makes them a highly sustainable source of protein, especially in the context of global food security and climate change. Efficient feed conversion. Insects are highly efficient at converting feed into edible body mass. For example, crickets require 6 times less feed than cattle to produce the same amount of protein. This feed efficiency means less natural resource use and lower costs, making insect farming a viable solution to feed the growing global population. Nutritional benefits. Insects are packed with high-quality protein, essential amino acids, and micronutrients like iron, zinc, and B vitamins. Some insects, such as mealworms and crickets, have a protein content comparable to that of beef, chicken, or fish. They also contain healthy fats and fiber, making them a well-rounded source of nutrition. Cultural acceptance and tradition. Many cultures around the world already consume insects as a regular part of their diet. In countries like Thailand, Mexico, and Nigeria, edible insects are a traditional food source. This cultural acceptance makes the transition to insect-based protein easier, as people are already familiar with their taste and nutritional value. Biodiversity and accessibility. Insects are diverse and can be harvested from a wide range of species, offering various textures and flavors. Their ability to thrive in different environments also makes them more accessible in rural or impoverished areas. This biodiversity can provide local communities with an adaptable and sustainable food source. Minimal land use for farming. Unlike livestock, which requires vast areas of land for grazing or growing feed crops, insects can be farmed in small spaces. They can even be raised on organic waste like food scraps, further reducing land use and promoting a circular food system. This makes insect farming ideal for urban farming initiatives and small-scale operations. Lower risk of disease transmission. Insect farming typically involves fewer risks of zoonotic diseases compared to livestock farming. Since insects are not prone to the same diseases as mammals, such as mad cow disease or swine flu, they present a safer alternative from a food safety standpoint, minimizing the potential for large-scale outbreaks. Energy and water efficiency. Raising insects requires significantly less water and energy than traditional animal farming. For example, crickets require only about a gallon of water to produce a pound of protein, compared to over 1,800 gallons for beef. This water efficiency makes insects an ideal choice for regions suffering from water scarcity or looking to conserve resources. Economic viability and job creation. As the demand for sustainable proteins grows, insect farming has the potential to stimulate economic growth by creating new industries and job opportunities. From insect farming to processing, packaging, and distribution, this emerging sector could provide employment in agriculture, food production, and research. Positive environmental impact. By reducing the need for traditional livestock farming, edible insects help reduce deforestation, soil degradation, and water pollution. They also produce significantly less methane, a potent greenhouse gas, during their life cycle. This makes insects a more eco-friendly protein option, contributing to global efforts to reduce environmental impacts.